Have you ever encountered a dataset that's so complex that it seemed impossible to clean? Ready to conquer even the most challenging data transformation and push the limit of Power Query beyond its user interface? In this video, we'll deep dive into M code and custom function to tackle the toughest data scenarios. If you're ready to become a data transformation master, then this video is for you. Let's get started. Hi everyone, my name is Lynn, your go-to expert for all things data and automation. Whether you're here to streamline your workflows or simply become an Excel bro, you'll come to the right place. On this channel, we'll turn data chaos into clarities. If you're new here, welcome to my channel. Make sure you hit that subscribe button and ring the notification bell so you never miss out on any of my data transformation tricks. In the previous videos, we've helped Excel Property, a popular property chain, to organize their timesheet data for multiple stores. We've combined data using dynamic array formulas and Power Query, handling relatively straightforward data structures. But now, we're taking it up a notch. Store 5 presents us with a highly complex data structure that requires more than just Power Query user interface to handle the data transformation task. We need more advanced technique to get this data into shape. So in this video, we will start by analyzing the complex dataset from Store 5, understanding its structure, and identify the challenges. I will show you how to import data from an external Excel workbook into Power Query. And we'll define some data transformation strategy, setting the stage for effective data transformation. Then we'll deep dive into performing advanced data transformation to shape the data structure at your will. And finally, we'll go beyond Power Query interface, deep dive into modifying M code and creating custom functions to tailor the data transformation precisely to your needs. Now before we start, you can download the data file using the link in the description box below. There's also a timeline that helps you to navigate through all the sections of the videos. Please feel free to pause, rewind the videos if you need to follow along at your own space. Ready to become a data transformation master? Let's dive into it! This is the dataset that we will be working with today. It is the employee's timesheet for Store 5 in Quarter 3. We have the planning date and the weekday in the first two columns. Then we have 4 employees, 19, 20, 21, and 22 in Store 5. Each employee has their own timesheet documented with the information of status, clock in and clock out time, and the approved overtime. And each timesheet is created separately for each month with the same structure. Now we need to convert this Excel workbook into a proper data set, like this. As you can see, it is a rather complex data structure to transform, and we would need to use more advanced data transformation technique to achieve the results we wanted. And I'm going to show you step by step how we could perform such complex data transformation tasks using Power Query. We're gonna start to import our data from a blank Excel worksheet. So go to Data, Get Data, from File, and from an Excel workbook. Now go to the folder where your files is located, select the files and click on Import. A pop-up will appear which allows you to preview the content of the Excel workbook. And there are currently 3 sheets which contain data. And if you click on them, you can have a preview of the data in the sheet. Now we want to select all the data from all the sheets. So instead of selecting a specific sheet, we're going to select the folders icon here. and then click Transform Data to activate Power Query window. Now I'm going to quickly rename our query to Master Combine. And let's take a look at the Power Query window here. We can see that Power Query has picked up all the metadata in the selected files and summarized them here. So we have the list of objects in the selected Excel workbook and their corresponding name. Now, if I click in the blank area in the data columns, I can see the preview of the content for each table in this column. We also have other metadata like the type of objects. Right now, with our selected Excels, we only have data stored in an Excel worksheet, but you can also have other type of objects like a table name or a defined name range. And you can also know if the object is hidden or not in the Excel workbook. Now, out of all this metadata information, we're only interested in two columns. The first one is the kind column because we only want data from the worksheet. So we need to apply some filter condition here in order to restrict the data to the sheet only. So click on the filter button here and select the sheet object only. Now the second column that we're interested in is the data column, which store all the timesheet information that we want to extract. Right now, they are stored separately in different sheets. So how do we combine them all together? You might be tempted to click on the expand button right here and combine all the data. But as you can see, the column headers are repeated many times in different columns for each different sheet. And we do not even have the employee ID column. We only have a single cells that contain this information. So we cannot just simply combine data like this without perform some other transformation. So I'm going to X this step out. All right, so it is a complex data structure. So how do we tackle this problem? We're gonna perform the transformation into two steps. The first step, we're going to perform the data transformation for one sheet at the time to transform it into a proper data set. And secondly, we're going to use these transformation steps and build a custom function which can be reused to apply the transformation for different sheets in the list here. From the master combine query, I'm going to make a duplicate query and now rename it to transform step. I'm going to use this query as a transform template. I don't need this filter row step, so I'm going to X them out. Right, so let's start from here. From this list of objects, what I want to do is to get to the underlying data from one of these objects here. Let's say I want July data. What I need to do is to click on the table and Power Query will navigate and get me the underlying data of July. Now what we need to do is to convert this data set into a proper data set. There are three powerful transformation functionalities in Power Query that can help you to shape data into any format that you want. Those functionalities are Transpose, Unpivot column, and Pivot column. Let's go through them one by one. Notice that we have some blank column here that we need to remove, but not static like this. We need to remove it in a dynamic way. We cannot do that with this data structure as a column. However, we could do that easily if the data structure is a row instead of column. And that's where Transpose come into handy. So let's do that. Let's just remove this step for now and click on Transpose. As you can see here, the column dimension is switched to the row dimension. Now we can simply filter out the null line, and we have that filter out. And we want the employee ID to be repeated to all of these rows. So select the column, in fill, choose fill down. And we have what we wanted. Now I'm going to just transpose this dataset back to the original stage. Click Transpose. And we've dynamically removed all the blank column, and we already made all the employee ID repeated throughout all of these columns. But we have a problem here. We cannot use the first row as a header because we have two line headers. So the trick is to go back to one step before the transpose, and we're going to merge these two columns. So click on the column 1 on your keyboard, click Shift and select column 2. Now we're going to merge these two columns. Power Query asks me if I want to insert a step before the transpose step. I'm okay with it, so click on Insert and hit OK to merge these two columns. And now if we go back to the transpose step, we can now see that we only have one column header. So I can use the first row as a header. And we have a new data structure here. For employee 19, we have column status, clock in, clock out, and overtime. And then the pattern repeat for other employee 20, 21, and 22. So the column header, which contains the employee ID, should become the row instead of staying in the column headers. So how do we make these column headers become rows? This is where Unpivot column come into handy. Now, out of all of these columns, we only want to keep the weekday and the date column. So I'm going to select them. Now go to Transform, Unpivot column. Click on the arrow down here and choose Unpivot other columns. And we've unpivot our current data structure to a new data structure. And as you can see, the employee's ID repeated for every single rows. Now we only need to extract the employee ID from all the other column headers. And we can easily do that with the split column function. So select the column, choose split column, and split by number of characters. I want only 2 characters, and I only want to split one time from the left. So that will be the first option here. And I want this column to be named employee ID. So instead of rename it and create an extra step here, I can just simply adjust the formula so that I can have the column name directly from the formula. Now we have the new data structure. The status, clock in, clock out, and overtime are now in the same column with their corresponding value. These are different data types, so they should not be stored in the same column and they should be in separate column. So what we need to do is to pivot these rows into column. So select the attribute column, click pivot column. Now the underlying data that we want to pivot is the value column. And we do not want to aggregate, so select advanced option and choose don't aggregate. So we will retrieve the original value from this column. And we have the data structure as we want it. Now for some minor adjustment, we need to reorder the column. So simply drag and drop it to the position that you want. And also I'm going to change data type as well. And we've successfully transformed our messy data into a proper dataset using advanced functions like Transpose, Unpivot column, and Pivot column. Now it's time to replicate all of these transformation steps as a custom function to help us to perform data transformation to other sheets in the workbook. First, we'll need a strategy on how we're going to create this custom function. Look no further. We'll replicate the basics of Power Query engine when it comes to combining multiple files in a folder. I have a video that explains this step in details. I'll leave the link to that video, so please feel free to check it out. Now, basically, we will need to have our main query with a list of objects to be transformed and another 4 helper queries. First is the sample query, which help Power Query to understand how the underlying data in each object is structured. Then we have the parameter query, which hold the value of the sample query. This parameter acts as the controller, which the next query, transform steps, reference form. Any transformation step applied in this query will impact only one file, that is the sample file. And finally, we have the function, which is in sync with transform query. The function can be invoked to extract the underlying data for each individual object within the list of the main query. Now, out of these 5 components, we've already have the main query, which is the master combine. We also completed the complex transformation task with query transformation steps. The missing components are the sample query, the parameter query, and the function query. I'll show you how to create each missing component one by one. To start, we're going to duplicate the main query and extract only one sample table to serve as the basics of our custom function. So right-click on the main query and duplicate the query. Now I'm going to rename this into one sample. We don't need the filter step here, so I'm going to exit out. Now, what we need to do is to navigate to the data of one of the sheets in this list. And I'm going to go with the July as a sample. So click on the table. And we have our sample query ready. Next up, we're going to need to create a parameter which we'll use to hold the query sample one here. So go to Home and click Manage Parameters, New Parameters. I'm going to name this query toParameter. Now we need the required checkbox to be ticked. The data type is any, suggested value is any. Now for the current value, I'm going to input one sample and hit OK. As you can see, the parameter query right now is holding one sample, but this is in the text format. That's not what we want. We want this parameter to hold the query sample, which is the table. So the data type that we want is not text, it's binary. We're not going to be able to update this data type from here. We need to use the advanced editor to update it. So this is the advanced editor window, and this is the M codes. It is automatically created when we define the parameter from the user interface here. This one sample files right now is in text, so it's in the color red. What we need to do is to make this text reference the query. So I'm gonna put the hashtag in front. Now you see that Power Query tells us that it identified the object query one sample. So I'm gonna click that. The M codes is reference this query right here. And we also need to define the data type that is binary. So I'm going to use binary identifier equal. And we need the query sample file. So copy and paste and comma. Okay, now hit done. And as you can see, the parameter is now reference this sample query, and the text value here has been grayed out. Now, the third step is to create a query transformation step. But lucky for us, we've already created these transformation previously. So I'm just going to move it down here and rename it into 3 transformation step. Now what we need to do is to link this transformation step with the parameter query. To do that, we need to go back to the source. Here you can see that this is referenced from the Excel file itself. Now we need to change that into to parameter. This is the parameter query, so we reference that. I can see that there's an error here, so let's see what's going on. So this is okay. The next step is the navigation, which we do not need it anymore because right now we already navigate directly into the sample file. So I'm going to X this step out. And there's no more error in our query. So click on the last step here. We have all our transformation steps done without any error. And the final helper query is the function. So right click on the transformation step and click on create function. I'm going to name this for_function and hit OK. Power Query created the function query here, and it automatically grouped the 3 related queries together in a folder called function, which is the same name as the name of our function. I'm just going to quickly move the helper query here in the order of creation. And now let's have a closer look at this newly created function. In the formula bar, I can see the M code behind this function, which happened to be exactly the same transformation step as in the query transform steps. And because this function is created from these transformation steps, so they are linked together, any changes from the transformation step here will be automatically reflected in the function. So for example, if I X out the change data type here in the function, we will not see the change data type steps anymore. Now let's add back the change data type here and look at our function. It's automatically updated. Now that we've successfully created all our helper queries, all of the components and the functions, we can now use this function to help us to perform data transformation in our main query, specifically for each of the underlying data in this master combined query. Now I'm going to use this function by selecting the data column, go to add column, invoke custom function. Now I'm going to name it fx, short for function, and the function that we want is for function, which is this function right here. And we want to apply that into the data column, which is the column right here with the underlying data, and hit OK. A new column with the name fx is created. And if you click on the blank area here, you can see the original data has been transformed by this function into a clean and proper data set, and it applying for all of the sheets within the Excel workbook. And of course, we can use expand button here in order to combine the data from all of the sheets. But first, let's remove all the columns that we no longer need. So right-click on the function column and remove other column. Now click on this expand button over here, untick the box, use original column names as prefix, and hit OK. And we have our proper data set created and combined all together for all of the sheets, July, August, and September here. But we're not done yet. There are some minor tweaks that we need to make in order to have our data transformation process fully dynamic. So let me explain. Let's go back to our query 3 transpose step. Let's say if I want all the record that is holiday only, I'm going to filter on the status column the holiday. So now in master combine query, we're going to have only the holiday record appear. So the row dimension worked just fine. What about the column dimension? Let's go back to our transpose step. What if I want to add another column right here? Let's say I want to extract the month value from the date. So go to add column, date, month, and the name of the month. If I add the month name here, go to the master combined, we do not see the month name column added here. So what's wrong with our query? It doesn't work dynamically. Why is that? It is because in this expand function step, we can see that the column names are hard-coded right here, and that's not what we want. So the trick here is to make this part of the codes not hard-coded, but dynamically change. And how we're going to do that? We're going to use a function called table.columnName. Open and close brackets. Now what we need from this table.columnName is the table we want to reference, and we want the header of this query. So that would be 3 underscore transform staff, hit enter, and the month name column is added accordingly. If I go back to this transformation steps, remove the column name here, and also remove the filter. Now go back to the master combine query. The month name column is automatically deleted. All right, now I'm gonna quickly sort this employee ID, and we're ready to load our proper data set into the Excel workbook. So go to home, close and load too. And because we have so many helper query right here, I'm gonna just load everything as a connection for now. Now right-click on the master combine, choose load to, and I want to load this master combine query as a physical table in the Excel workbook. And hit OK. And we have all of our data loaded into the workbook successfully. We now have new data for quarter 4 for store 5. Let's see if our data is updated. So I'm going to drag and drop the new data into our Excel's workbook. Save and close. Now, if I right-click and refresh the query, I can see that the date information has been updated with the quarter 4 data. And that's look good. And we've successfully cleaned and combined the messy data from multiple Excel worksheets into one clean and proper data set ready for analysis. Congratulations, you've done it! You've reached the final episode in our data transformation journey. In this series, we'll tackle messy timesheets data from different stores of Excel property using varieties of techniques from basic dynamic array formula to advanced Power Query transformations and custom functions. You're now equipped with powerful knowledge to transform any data at ease. Please apply these techniques to your work and don't forget to share your experience and success. But our journey doesn't end here. Now that we've transformed and cleaned our data, we're ready to analyze and draw meaningful insights. So in the next part of the series, we'll deep dive into analyzing the timesheet data to help Excel property uncover crucial insights, aiding them in better planning and hiring decisions for the next year. Stay tuned as we'll dive into data analysis to uncover important insights that drive decision making. I hope you found today's tutorial helpful, and I hope it empowers you to take control of your data like never before. If you enjoyed these videos, please give us a thumbs up and share with your friends and colleagues. And please leave a comment below if you have questions or suggestions for future topics. And don't forget to subscribe to my channel and ring the notification bell so you never miss out on any updates. Thank you for watching, and I'll see you next time.